Okay, we're going to try to do this as quick as we can so you don't miss the next talk if you're going to another room. Thank you so much for moving all the way up here. We're really, really sorry. I hope it's worth it. My name is Marcus. I work at Tinder as a senior Android engineer.
My name is Bret Erickson. I'm an engineering manager also at Tinder.
Yeah, and we're here to talk about MVVM, nested fragment views, ViewModel Contracts. It's a lot of words. I hope it's going to make sense in a few seconds or minutes. So let's get started.
Cool. So,
oh, sorry, you have that one. I'll keep that.
Motivation for this talk, just really quick. We had a number of complex layouts in our Tinder's Android app, and we had a bunch of fragments that were communicating with each other, and the old interface callback pattern was kind of falling over. We're thinking about doing like RX subjects, and Marcos here came up with a better idea to integrate with MVVM that had a sort of a cleaner decoupled pattern that led to the idea of ViewModel contracts.
But before we get into the nitty-gritty, let's go through the memory lane here. Does anybody recognize this? This is Honeycomb, our favorite OS, right? It came out in 2011, and it was in the Motorola Zoom. I don't know if anybody bought one. I did. It was a mistake. Starting at that point, we're starting to have more complex and dynamic views, and we were introduced to fragments that everybody loves and hates at the same time. Tablets nowadays are nowhere to be seen, but phones are getting bigger, right? Like we have 6-inch phones, and we think that's fine. I like it. I'm not complaining. And then apps are becoming more and more complex too. And with all those views and things that are going on at the same time, and sometimes fragments and views that we need to reuse, how can we make the communication of them to be more efficient? It's a question that we often ask ourselves, and at Tinder we ask ourselves all the time, and that's why we came up with this subject of this talk today. So let's think about some of the solutions. For example, at some point, having intent broadcasts and bundles was something that it was recommended, and it was something okay to make the communication between fragments, right? I'm not gonna go into details of that because we all know what happens when we use that. So let's just like skip this part. But another solution that we may have is callback and interfaces. But what happens in there? We can have on-click listens implemented by activities, so we can have that communication going. But that creates kind of a callback hell, right? Like that thing that no one likes. That's why Java is so popular nowadays. Cast activity into an interface inside the fragment, so we can have the communication going. But what if we want to reuse it inside another fragment? Then it would be complicated. And view controllers juggle communication logic a lot. So it's a pattern that it works until the point that your app becomes very complex. Another solution is RX subject. But honestly, at the end, it's just a fancy alternative to event bus. Injecting an RX subject into a fragment may expose some mutable logic and mutable values that you don't want it to happen. You can like go around it by creating interfaces and only exposing what you really want, but it can cause a lot of problems. And RX subjects are not faulty tolerant, like one error emitted and you're done. And it's difficult to debug here and there. Sometimes a value is changing and you don't know where it's coming from. Somewhere else in your app in the background is calling that subject and you're like, oh my God, where is this from? Why is my data changing? So if we take a very quick look at the popular architectures that we have nowadays, the domain and data layer is usually very well established. Some people may have some doubts or some different preferences, but most of the time we're gonna have in the data layer, we're gonna have repository, a data store, a client. Sometimes in the domain, we're gonna have an interface to make the communication going, and use cases if you're using clean architecture. And the UI, it's where usually questions rise, like, am I going to use view models? Am I going to use view presenters? Am I going to use fragments? Am I going to use custom views? Like, now there is compose, and it's like, Jesus, chill. So if we take a look here on the UI part of it, what are the doubts that usually come when we're using MVVM? Should I use one view model for multiple fragments? Or is it okay to have view models for custom views? That's a question that we can come up to when we're using it and trying to figure out complex apps with MVVM. And should we share a view model across multiple UI elements? Google recommends it, but is it really the best solution that we have out there? And that's why we're introducing ViewModel contracts for a lack of better name. But before we go into the details and the nitty-gritty of how it works and what it's about, let's take a look and analyze a quick and simple problem that we usually have.
Cool. So building off of a more complex example that might be relatable is a number of apps have like some sort of registration flow. So we're going to talk about how we could potentially build that, and then later on, after explaining ViewModel contracts, how we could improve on that solution. So starting off with the feature requirements, we have a couple of separate screens, starting with the user entering a username, an email, and then some selected interests of whatever type that they want. And I have some really high quality UI for a demo app that's going to show going through those steps, just so you have kind of a visualization. And how could we potentially implement that? And maybe a very naive basic solution would be to have each step in the flow have its own activity. But I think we can improve on that, maybe using like the older interface callback pattern. And how would that potentially look? Let's go through like the different pieces that are involved here. We're starting off with the activity. The activity is going to be communicating with some sort of view model with its own live data, maybe representing the entire state for the registration flow. And then we're going to have fragments for individual screens. And this example here, we're just talking about the username fragment. And then that fragment is going to declare its own callback to have upwards communication back to the activity. And then the activity is going to implement that. But let's say we have some feature creep. You've built your registration flow. Now the PM has come up to you at the last second going like, oh, our users think it would be really great if we had a persistent UI on the screen showing all the registration steps. And that persistent thing is going to have some extra UI, kind of show like some check marks and stuff. Maybe it's a card that sits on the screen sort of like this. And ultimately what they're looking for is something that augments our really awesome demo app with that persistent little check mark box as the users fill out each individual step. So we want to refactor, and knowing that we're using that callback pattern, we're kind of running into a little bit of friction where the activity is acting as a mediator, where we have the users submitting information in the username fragment, and then that has to get routed back into the activities view model. But we're also routing information down into the progress fragment, and those it's getting a little crusty. So maybe we can come up with a better solution. And leaning on Google's guidance, their documentation suggests leveraging MVVM with a shared view model that can have all the fragments sort of observe the parent's view model. And revisiting our original diagram, we're going to have that callback that we talked about before, and we're just going to essentially delete that and then just have all the fragments depend directly on the parent's view model. And then knowing that we have a whole bunch of fragments involved in this flow, we basically have a whole bunch of stuff now depending on the parent's view model. And this is okay, but I think we can do this a little bit better with the ViewModel Contracts concept. But I'm going to let Marcus kind of do a quick refresher on MVVM and then walk us into the ViewModel Contract concept.
Yeah, so let's go very quick onto LiveData and ViewModel. If we're here and we're talking about contracts and a little bit more advanced topic, I expect you to have some knowledge on LiveData and ViewModel. So I hope you do. But if you don't, very quick, a LiveData, the way it works, it's just basically a behavioral subject, which means simply that every time you subscribe to it, it emits the latest value. And observations can be attached to a lifecycle, which is pretty cool because then you don't have to care about removing observers, adding observers, and things like that. Now, if we look at the view model, though, it's different and it's pretty cool because it survives longer than an activity or fragment does. Like if any configuration changes happens, the view model will still be there and will still be holding the data that we need inside of it, right? Cool. So if we think about the shared view model part of it that Google suggests us to use, the way it works is right here, we ask for the view model using the view model provider, and then we pass the activity. Because that view model is on the activity scope, and every time we're asking for that view model, we're passing the activity as a provider, we will always get the same instance in every single fragment, and that's how we can reuse it as a shared view model. But let's take a look at the code. Let's take a look at the source code of this and see how it works behind the scenes very quick. So if we're going that get method that receives a class, basically what it's doing right here, it's getting the canonical name of that class, and then it's checking if it's a real class or if it's just like a inner class. That is fine. And then it calls get with a default key and like 2 dots and a canonical name and a model class. Like, what's going on in there? So let's take a look at that method too. So when we go there, we can see here that it's going to get the view model using that key, which that key basically we just saw is the name of that class, basically with some prefix. And then it checks if the model class that we got as an instance of view model, and then we can. But I mean, let's just go back here very quick. Does that mean that our view model is just stored on a map, and we just get it with a key, and then that's it? That's all? I mean, if it's that, why can't I use my own string? Why do I have to use a class? I mean, if we look at the implementation, it gets clear why we need to use a class. We need to instantiate it if we can find it, so we can store it on the map. But it makes me beg the question, like, how can we take advantage of that knowledge? Knowing how view models are retrieved, how can we make it like a little bit better so we can improve this flow of shared view models? And that's the question that we asked. We realize here by looking at the code that when we don't find an instance for that class canonical name, we then make a new instance to add it to the map. And that's how we have a new view model if we're trying to look for one and it doesn't exist yet. Now, if we want the class of the view, if we have the class of the view model that we want, then can we just pass that information to our fragments and have a look for the view model for that class? And another question that you may ask yourself by looking at the source code is, can we access the parent view model without knowing what that parent view model is? Because if we can, then that means that our fragments are extremely reusable and I can attach it to anything, right? Well, the question here, the answer to those questions is yes, we can. And that's what ViewModel contracts are about. So let me explain you on a high level what it means. So let's take the example that Bret talked earlier, where we have the registration activity on the top there, and then we have the registration view model right here. Like, we have that communication that they're all sharing that view model, but let's make it different. Let's try to use ViewModel contracts and see what it's about. So let's imagine, let's put this aside, and let's imagine here that the username fragment will declare an interface. And that interface right there declares everything that it wants to do on the parent view model. It declares the methods that it wants to be able to change, and it declares the information that it wants to have access to. But it's just an interface. We do the same for the email fragment. We do the same for the interest fragment. And then we do the same for the progress fragment. So now I have those interfaces that we expect to be a view model. We're calling here a view model contract that we expect to have access to some properties. And now we just make the registration view model to implement those interfaces. Implement the username fragment view model contract, implement the email fragment view model contract, and for all the other ones too. Now, if we have that, when we instantiate those fragments in our activity, we could just pass in the argument that class. Well, class is a serializable object. So if I have a key that each of my fragments is declaring, and I can pass that class, then inside of my view of my fragment, I can simply do view provider of and get the argument with the key, which my argument with the key, it's the name, it's the class of my view model on the parent. But what's really cool about that is that at that moment, if we go back here, I can then cast, in this case, to use my username fragment view model contract. And because my parent view model is respecting that contract, is implementing that interface, then I'll be able to do the operations that I wanted to do. But in any moment, my username fragment will have any reference to the registration view model. It won't know who it is. It won't know its name. It doesn't need to know anything. And it makes it extremely reusable, and it makes it like very plug and play. So now at this moment, we have here on the username fragment, we have an instance of the view model, but by using the contract, by using that interface. The same thing for the email, same thing for the interest fragment, and same thing for the progress fragment. And that's how we can have it really like decoupled and have access to the parent without really calling for the parent itself. But what's really interesting about that is that let's imagine a case where we're like putting those fragments aside, and then now we need to reuse those fragments in this process inside of another fragment, because now we're in a tablet or we're in a Chromebook and our app is much more complex, and we want to be able to have the same flow but inside of a fragment now. And now it's a registration master fragment and a registration master view model. Well, what's really cool here is that as long as that view model, it's implementing those interfaces and those contracts, and as long as when we're instantiating those fragments, we're passing that key and we're passing that class as an argument for those fragments, they just work. They just plug and play. We have to make no changes for any of those child fragments that wants to use the communication from that view model. This was a very high level explanation of it, but to go really into details, Bret's gonna show you code and how we can implement it and how we can really how we use this concept to implement the app that we just showed you.
Cool, thanks, Marcus. So yeah, let's revisit our original example. We have this shared view model concept. I'm just going to focus on one fragment for simplicity, and just to revisit what the progress fragment does is it's got that little card with the check marks. It only really needs to know, like, is the username done or is the email there, and so on. In order to implement the view model contract theory that Marcus spoke of, we need to declare our own view model contract with our own live data that represents only what the progress fragment cares about, not the overarching registration flow state. And then we're going to move on to step 2, which is instead of having the direct dependency on the parent view model, we're going to remove that tightly coupled reference and just have the progress fragment leverage the view model contract as if it was a real view model. And we're going to go update our registration activity to make sure that we're passing in that class to the fragments arguments. And then at that point, the activity is essentially completely out of the way. There's no sort of like mediator behaviors that the activity is responsible for. And then lastly, we're going to update our parent view model to implement the interface and then satisfy the contract with the required live data the progress fragment needs. So here comes some code. Please be patient. But we're going to walk through it step by step in those kind of like 4 steps that I outlined. And the first part is talking about the data and the live data that wraps it, that the progress fragment cares about. And like I mentioned, we have a registration flow with a number of things flying around, but that widget only really cares about is the username there. And we're representing that with just some basic Booleans. And then we're exposing that to the fragment through the view model contract, which is just an interface that declares some live data. Moving on to step 2, which is updating the fragment. We're going to have a property that's a reference to the contract instead of the parent view model. And then we're going to leverage some extension functions, but does a little magic for us to get a hold of that view model for us. And then we're going to be able to use that view model contract like it was a regular view model, observing the live data and making updates to the UI as necessary. So what is the magic in the extension function? This is essentially a simplified version of what Marco spoke of, which is we get the key from the class from the fragments arguments. Then we're going to go ahead and grab the view model provider from the enclosing activity, or this could be expanded hypothetically to look at like parent fragments and stuff too. But and then once we get a hold of that, we're going to just do the quick lookup and see, is there a class that matches our contract, and then cast it to what the fragment is expecting. And in order to enforce that, I mentioned that the activity is responsible for passing that key in. So in order to own that responsibility, the fragment itself is just going to use a kind of a basic new instance pattern. That's going to be the sort of fragment creational factory for passing in the contract. And then we're going to use, jumped ahead. We're going to use another just quick top level function just to do the adding of this key to the bundle. And just a quick look at that. That's kind of what we have here. We're just simply abstracting out the boilerplate. Moving on to the activity, as I mentioned, is just responsible for creating the fragment now. It doesn't have any other logic for mediating data from one fragment to another. It's just creating the new object and then adding it. And then in order to satisfy the new instance call that we just created in the fragment, we're going to take the activities ViewModel property and then just pass that into the new instance call. And then moving on to, I'm moving really quickly because of time, apologies. Last step I mentioned, which is having the parent ViewModel implement the contract. So looking at the registration ViewModel, we have LiveData that represents the overall state. And like I said, this has a whole bunch of stuff that the progress fragment doesn't care about. The first step is implementing the interface that satisfies the contract. And that's going to force us to override the LiveData that the interface declares. And then we need to do something with that. And what does that look like? In this case, we can leverage LiveData transformations to take the high-level state and distill it down into those basic booleans that the progress fragment is expecting. So should we skip this?
Someone wants to take a picture. I saw some people trying to take pictures of the screen. Sorry.
Moving on. So I mentioned some extension functions and some like fragment, new instance calls and things like that. At Tinder, we've been iterating on this pattern, and we've actually come up with some lazy Lambda functions and stuff that kind of make it feel a little bit more like real view models and simplify some of those details. And it's kind of beyond this talk, but just to kind of quickly show what it could look like. Going back to our fragment, we have that the ViewModel contract as a property. And then we have the extension function and onViewCreated, and then the companion object. We can actually simplify that to just use the by ViewModel contracts call to get a hold of our property, and then we just use it like a regular view model.
So the key takeaways here is that by using ViewModel contracts, which is the interface definition, it helps us to have very decoupled fragments, because like I showed before, that those child fragments need to have no information about its parents. It needs to have no idea who that view model is. So it makes it very plug and play. I can just remove it and plug it somewhere else, as long as whoever else it's using that fragment is respecting that interface and is respecting that contract. So the contract almost acts like an API that defines what you need to give me so I can work properly. It reduces the scope, because then the child fragment doesn't need to have so much information from the parent fragment, like a whole set of states, a whole set of properties that it doesn't care about. And it improves reusability, just like I just mentioned, and allows you to really get that fragment and use it somewhere else, use it inside another fragment, use it inside of another activity, and makes it completely cleaner and easier to use. And that is it. Thank you. We went through very fast through it. I hope we were able to pass the idea. If you want to see how we implemented the app and you want to go through the code, we have this on GitHub. You can take a picture. We have a QR code to make it easier. You can go there. We have all the code of the examples of the sample. There's all the codes on how contract works, how we declare them, how you can use extension functions to make your code cleaner and to make it more easy to use. And you can really debug everything and see how we were able to make this work, and how we can have a better solution than use shared view model that allows you to have a more flexibility on your UI. Thank you very much.
Thank you.